So we're looking here at quadratic equations. Previously I mentioned linear equations, that they had the form ax plus b. X is our term here, a is our multiplier of x, and b can be an integer or term. Quadratic equations are different in the sense that they have a squared term, they have a term, and they have a term slash integer, so they have an extra species in the equation as opposed to linear equations. So the quadratic equation has the form ax squared plus bx plus c, where we have an x squared term, a term, and a term slash integer. So a lot of the times quadratic equations are made equal to 0 in order to solve for their roots or their solutions, which, like I said, are called roots. So in this case, a, b and c are known numbers, and x is an unknown quantity which we need to solve for. We're solving for the roots. So some examples of quadratic equations would be as follows. Two x squared plus 7x minus 3 equals 0. Another one would be x squared plus x plus 1 equals 0. Just to show you as well that the multiplier of x squared here can also be a fraction as well. It can be, because it is a number. So we could have something like this. So we could have a half x squared plus 3x plus 9 equals 0. And that's classed as a quadratic equation as well. So quadratic equations. Now, quadratic equations can be solved for their roots in 4 ways. So we have the factorization, which I like to call the sum product rule, which I'll explain to you in a second. Then we have the quadratic formula. Way of completing the square. And we also have solution using graphs. So to start off, we're going to look at the product and sum rule. So to begin with, I'm going to take a simple quadratic formula. We're going to take x squared plus x minus 6 equals 0. So this is our quadratic equation. Now what I like to do is I like to use the sum product rule. This is how I was taught it in school, and I've used it ever since, even all throughout university and college. So what you want to do is you want to draw out like a table, and you want to have P and S indicating your product and your sum. So let's draw our product and our sum table. Now, product means the product of the A and C term. So if we look here, our A term in this case, because it's just x squared, is 1, the same as writing 1x squared. This is our A term for our quadratic equation. Back up here, if we look at our general formula, and like I said, the product term is the product of the A term and the C term. So C in this case is minus 6. So 1 times minus 6 is minus 6. Our sum term is our value for our B term. So in this case it's just 1. So what we want to do is we want to find two numbers that multiply together to give minus 6 and add together to give 1. So we can list all the factors of minus 6. So in order to get minus 6, we can do minus 1 times 6. We can do 6 times minus 1. We can do, let's see, minus 3 times 2. Or we can do minus 2 times 3. Now, looking at these terms, we can see, or I can see, that this is deemed the correct answer and the most possible. So if we add minus 2 to 3, we get 1. We add them together, and if we multiply them together, we get our minus 6, which is our product term. So this is the set of numbers that we're going to use. So we rewrite our equation using these numbers instead of putting in our B term. So writing our equation again, we have x squared minus 2x plus 3x minus 6 equals 0. So looking at that, we can see we've rearranged, we've put these two terms in here from our product and sum rule, and we've put them into our general equation by using these two to rewrite our B term up here, which is x. So next bit of paper, we have x squared minus 2x plus 3x minus 6 equals 0. Now if we wanted to factorize that down and take out some x terms, we can. It's the same way as having an a or an a squared or a b and a b squared. So what we do is we rewrite that, and instead of x squared we write x upon, so if you divide x into x squared, you just get x. Divide x into minus 2x, you get minus 2. Then similarly on the other side, we have plus 3 upon x minus 2, because plus 3 multiplied by minus 2 gives us minus 6, which is what we have in the line above there. So okay, so now that we have our equation rewritten in this form, right, we're able to see now that this top line can be rewritten as this. Now in order to get your two factors or your two roots, we need to rewrite the equation in a form of a thing called a double bracket. So we look at our first set of terms that's common in both, which is x minus 2, we write that down. And then we also look at what's outside the brackets. So we have an x here and we have a plus 3 over here, so that's x plus 3. And that is factorising the quadratic equation. That is the two factors that go into that equation. And in order to get our roots for x, because it said above that the equation was all written and equal to 0, we can do exactly the same thing down below. So instead of it x minus 2 upon x plus 3 equals 0, we have x minus 2 equals 0, x plus 3 equals 0. And then we solve for x the same way as we did in our linear equation back in the first part of this lesson. So we have, for this case, x is equal to 2. We take our negative term over, make it positive, and x is equal to minus 3. So these two answers are what we call the roots of the quadratic equation.